Yes, welcome back to Opioz Laboratory. It's a delight to always have you guys here, and your time will never be taken for granted. Now, in the previous video, we dealt with a smartphone battery build, and today I thought I should take you through things that you need to know to be able to deal with smartphone batteries, and therefore diagnosing and troubleshooting the fault as being that of the battery, and maybe if you are unable to replace it because of cost issues or availability issues, then you should be able to build or at least come up with something that will help you run the device. So anyway, I like to begin this video by saying that I need to tell you the uses of the battery before I proceed to do anything about the battery review. And part of the uses of the battery is one, simply to provide charge or store charge such that you are able to have it when you need it. Basically, because most smartphones do not actually run on a charger like you would see a laptop, it's inevitable that the battery simply runs the phone. Supplies it power so as to allow it to run. Now, the other thing is that the battery sort of allows convenience, and in a sense, you want to have a battery that takes long. So that is it as regards the use, basically to provide power, having stored it. Now, next step is to look at the parts of the battery. You might be wondering, when we talk of smartphone batteries, we are interested in basically two parts, and the first of which being the accumulator. The accumulator acts as a store of charge, and then definitely the second part of the battery is, as we said earlier on in the previous video, the battery management circuit. Now, the accumulator, being a store of energy, basically runs by two chemistries, and the chemistry is such that when you are charging, the equilibrium is shifted to one direction, and when you start using, the equilibrium shifts to another. But that's a story of another day. We will bring it in one of the theoretical videos where we talk about primary and secondary cells and therefore accumulators. Anyway, I think let me just show you two of these parts so that you're able to distinguish them. I'm just going to give you two examples of a battery and show you what I mean by accumulator and then the battery management circuit. Now, for instance, look at this battery. This battery belongs to a Techno smartphone, and when you look at it critically, you will see components right there. Some transistors, some fuses, and capacitors, and these are here simply to constitute what the battery management circuit is. And then this box that you see right here is the accumulator. Now, same is with the Sony battery that we have right here. We have a battery management circuit stored right in there, and then the accumulator being that box. Now, in just a moment, I will tell you what the use of the accumulator is and what the use of the battery management circuit is. This is an iPhone battery, and it's a replacement one that was recently bought, and you can see it's still in its seal. And also this has the same thing, the accumulator and then battery management circuit that ends up into the terminals. Now, today I thought we should talk a little more about the accumulator to allow you. Okay, so as we speak about the accumulator, I need you to note one or two things. Now, the accumulator is the main guy that is dealing with storage. In other words, the chemistry inside allows it to retain charge, which it dissipates when you decide to drain the charger and to decide to charge the battery actually. And for smartphones, as is for recent laptops, we are interested in the chemistry of lithium ion battery. So lithium ion battery, normally most people just call it Lion for the sake of I know, but it's lithium polymer, like you would see written right there. right there. Now I feel like I should show you how to be able to detect that an accumulator is good or bad. Now to let you appreciate that, let me just finish this word. It's a lithium polymer, to avoid any confusions. So one or two things I think you may have to notice about the lithium ion polymers is, one, that when it is at 0%, like it should actually read the voltage of around 3.3 volts, and then when you charge it up to 100%, you expect it to read roughly 4 volts. And that also helps to inform you that for you to be able to charge this battery to full, you need roughly a voltage above 4. In most cases we use 4.5 volts for safety reasons. That means a charger that supplies a voltage slightly higher than the maximum that the battery reaches when it is fully charged will help raise the voltage to when it's fully charged. Now, why am I telling you these two things? Now, these two things sort of help you to realize whether your accumulator here is good. And I think I want to bring a multimeter and just take for you a measurement of one of the accumulators to help you understand what I am describing right here. Now my multimeter is already here, and I wanted to take measurements of the accumulator and just show you. Now right now we want to just figure out that the accumulator is good or not good. So first thing is to put our voltmeter into the our multimeter into the voltage mode. And because these batteries when fully charged measure 4 volts, so we have to set it to the highest voltage closest to this, the higher setting closest to this, which is 20. 200 is very far, much as it's higher than that, but still you will get a reading. But for accuracy issues, we do set it there. Now this red is the positive probe of my multimeter, and this black is the negative probe. So when I get a value there that is positive, that means I've put the positive probe on the positive probe of the battery, and the negative accordingly. If it is negative, that means it's the reverse. So that also helps you tell which terminal is positive and which one is negative. Now if you're lucky and the battery management board is still attached, normally there's indicated negative and then positive right there. So here I'm going to do this because that's what's written, and put this over the terminals. Now you notice it reads 0.4. Now this accumulator is basically useless. These accumulators, normally you're not supposed to allow it to go to 0. That's usually deadly for it. Now I wanted to bring another accumulator. There's one that is of this form factor, but this form factor is a little old. It doesn't mean you won't encounter it recently. Now for it, there's this outer plate which tends to be the positive, and then that middle that tends to be the negative. So let me just put a probe here and measure, and we see what voltage reads. Now that one reads 3.9, so this is almost close to full. And this means this battery is likely good because it has been stashed away for long, but it still holds its voltage. I'll also show you another thing, that at times, in as much as it still has charge, at times it may not hold charge for long. Now those are scenarios whereby, like you would see this, it's a little swollen and bulged out like that. This one's capacity tends to be reduced because this is an effect of gas formed when the chemistry starts deteriorating. But now this battery is the form factor that is in here, and also is the case with this. These are the removable type, and if you look at it carefully, you'll also notice that it has this accumulator, and then it has this tiny circuit right here with components over it, and that goes to the terminals. So after the battery management, the next thing is the terminals. For inbuilt ones, the terminals are made such that they are sort of in ribbon form, and it plugs in, whereas this just cast as a monolith. Now I want to also take a voltage across this. At times, if the accumulator has a voltage across, the next thing is to measure if it's being let through by the battery management system to this other end. And when we measure, that's actually at 4 volts. That means it is full, and that value is a positive value. So that means I've put the positive probe on the positive probe, if you look carefully there. And if I were to reverse, just to let you know that the value becomes negative. So that's also a way of figuring out the polarity. Now, having said that, I think we've hinted on the idea of figuring out whether your accumulator is good or not. One, if you measure the voltage across an accumulator and it is zero, having sat for a very long time, it's likely that that one is actually dead, because if the voltage goes to 0 volts, that is clearly a dead battery. Oh yeah, but if it's at 0%, in other words, reading a voltage of about 3.3, that is fine. You can always raise that voltage. Now, let's just talk a little bit about the battery management system now that we have brought it up here. The battery management system is simply in charge of regulating the current that goes into and out of the battery, so as to prevent you from overcharging. So this one basically, not actually that, the battery management system is basically some sort of regulator, and this is to regulate the current being drained or the current being pushed into the battery. So that's the beauty of the battery management board. And as such, it also tends to have a tendency that when your voltage drops to 3.3 and below, it sort of disables the battery. You are unable to charge this battery, and in those cases it's very easy to misdiagnose the phone to having a battery problem. But a simple direct charging of the battery will raise its voltage to above 3, and then the charging IC of the battery will start detecting that there is a battery present. That's one of the things I felt like I should note. Then I think there's a thing worth noting is why is it that lithium ion or lithium polymer batteries are used when it comes to smartphones. One, the first thing is that it has a high energy density. In other words, you need a very small volume of it to store much charge, and unlike its alternative accumulators, for example, there are others. I'll mention them in the theoretical videos. I wouldn't want to bother you here. And then two is that they are rather a bit of very efficient due to that high energy density. Of course, I think that's to say there's also a bit of the lifespan, in that they sort of have a very long lifespan. In other words, I've seen smartphones that have run on the same lithium ion batteries for 4 or 5 years, and that is very interesting to behold. It tends to also tolerate high temperature environments. Like, for instance, you've noticed that when your phone heats up, you won't have your smartphone dying on you or your battery exploding on you. I think that lithium ion or lithium ion polymer batteries have as a beneficial feature. Now, I think to briefly recap what we've sort of dealt with today, I decided to push this video a little further because I thought it would be beneficial to, introduce a concept here and there that will prove beneficial. But that said, if you've reached this far in the video, I think and you're new to the channel, it's a bit prudent that I request you to subscribe, because our target as we stand is to hit 1,000 subscribers, and that will help us a lot. If you're a returning viewer, I thank you that you've reached this far, and I pray that you watch our videos from beginning to end so that we hit the 4,000 watch hours that are necessary for monetization. This will help us a lot towards improving the quality of content on this side. It will enable us acquire new equipment, new illustration models, and that should serve us well in making you happy. And it's our wish to be able to edify you, and in edifying you, happiness shall ensue. So that being said, I think that's it for today, and the whole essence of this video was to mention to you that a battery